Hey students, this is lesson 1.4. In this lesson we're going to learn how to find and compare the measures of angles. Again, notation is going to be critical here, so just kind of pay attention to that. Go ahead and do the review and I'll check back with you. All right, key concept is an angle. You can name an angle by its vertex. You can name an angle by a point on each ray and the vertex, or you can name an angle by a number. And you can see the examples here. So you could name an angle by its vertex. So we need to know the vertex. In this case, the vertex is A. 2 points that are not on the vertex are B and C. And the sides are the rays AB and ray AC. So to name the angle by its vertex, you could just call it angle A. To name it by a point on each side and the vertex, you would say either angle BAC or angle CAB. And to name it by its sides, or by a number, you would just use the number and the angle symbol. Like that. All right, so on problem 1, we want to name angles. What are 2 other names for angle 1? We can name it by its vertex, so we would call it angle M, or we could name it by the 3 letters of the angle, putting the vertex in the middle, and that would be angle M, N, N. Or you could do angle LMN or angle NML. Either way. All right, go ahead and try that, and I'll check back with you. So there's your answers. Note on this one that you are not going to name this angle M. Think about why that's true. All right, types of angles. You can have 4 types of angles, I guess, that we're concerned about here. Go ahead and see what you remember about those. Fill that in, and I'll put up your answers here so you can check them. All right, our postulate 1.7, our protractor postulate. Just like every point on a line has a number associated with it, a coordinate, every point on a protractor has a number associated with it, number of degrees from 0 to 180. All right, so we're going to use that idea to help us do this. We want to know the measures of angle LKN. So LKN. To do that one, we're going to measure it this way, since it's an obtuse angle, and that would be this row here. So we're going to say that the measure of LKN, we can do this a couple ways, and I'll just show you the difference. We can say LKN equals 130 degrees. Or if we're talking about the measure of those, then we're going to use a little M symbol to represent that, the measure of angle LKN. And then we're not going to use the degree symbol, then we're just talking about a number. So the measure is 130. So either way you want to do that. So that's LKN. Now we're going to do NKM. NKM, that's an acute angle, so we're going to measure from there to there that way. On the so that one, it looks like it's a little more than 50, so we'll say that's about 51. So I'm going to say the measure of angle NKM equals 51. And one more to do here. We want to measure JKN. So JKN, and that one is a 90-degree angle. So angle JKN equals 90 degrees. All right, I'm going to let you try that. All right, we can also use some other symbols to show angles that are the same. And when we're using angles, we use these little things. They look like rainbows. But if they have the same number of curves on them, then that indicates in the picture that they're congruent. So, so this angle right here that has three lines, three semicircle sort of things in there, that is equivalent to this angle right here. So those two angles are congruent, they have the same measurement. So what we're doing here is looking for one that is congruent to angle WBM. WBM is this angle right here. And notice it has one symbol there, so we're looking for another angle with one symbol, and that's that one. So, and we're going to use three letters to show that angle. You can't just use one letter because that could represent more than one. But we're going to say angle AEB. You could put AEM also for that angle. There are some other angles that are the same. We're not going to get into that right now, but for sure, because of the way they are marked, we know that those two angles are congruent. All right, go ahead and you try that. Okay, one other postulate here, angle addition postulate. If point B is in the interior of angle AOC, then measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. What we're saying is this, so if we call this angle ABT, and we put a point somewhere in the interior of that angle, say right here, and it could be anywhere, and we put angle L right there, create that ray, so we have two angles. What we're saying here is that the measure of angle ABL, which is this one, plus the measure of angle LBT, which is that one, is equal to the whole measure of the whole angle right there. So, and that would be ABT. All right, so we're going to use that postulate right now. If the measure of angle ABC here is 175, what are the measures of the other two angles? So, the measure of angle ABC, that's the whole angle, that's got to equal the measure of angle ABD plus the measure of angle DBC by the protractor postulate. Oh, sorry, wrong postulate, angle addition postulate. So the angle addition postulate. And now, let's just substitute expressions or values for each of these. The measure of angle ABC is 175. The measure of angle ABD is the expression 6x minus 5. And the measure of angle DBC is 4x plus 10. I'm just going to simplify that, and that was just substitution. And I'm going to simplify that. And I get 10x plus 5. And then I'm going to subtract 5 from both sides. Divide both sides by 10, and I get x is 17. Now that I know that x is 17, I'm going to just plug 17 in for x, and that's equal to 68 plus 10, which is 78. So this angle here is 78. And my other one, 6 times 17 minus 5, that would be 97, I believe. And those two together add up to 175. So that's good. All right, we'll try that. All right, there you go. Just to make sure you understand what's going on here, go ahead and do the lesson check, and we'll compare notes on that tomorrow. And that's it.